right, so 10.2. We're going to be solving systems of equations by graphing. So when we solve systems of equations by graphing, the point of intersection is our answer. So we find where the two lines intersect. That point is going to be our answer. So it's still going to be a coordinate point. You're going to have an x value and a y value, but you're just finding it a little bit differently. So there's a couple different ways that we can graph. In number 1, this is in slope-intercept form. So we can just start by finding the slope and the y-intercept. So what's our y-intercept here for the first equation?
Y equals 2x minus 3.
What's the y-intercept? -3. Remember, this is in the form of y equals mx plus b. So the b is our y-intercept. So we're going to cross the y-axis at -3. So I'm going to put a point there. And then our slope would be what? 2. Or 2 over 1. Because we like to think of the slope as rise over run. So we're going to go up 2 and to the right 1. Up 2 to the right 1, up 2 to the right 1. You can make as many points as you need. On Notability, it's nice because you can just hold the line and it'll connect the dots in a straight line for you. So that would be our first line. Yeah, I don't have Notability. In the second equation, so now we're going to graph our second line here. What's our y-intercept? 2. And what is our slope? -3. We'll call -3 over 1. So I put my y-intercept on my graph first. I'm going to put a point at 2. And then my slope is going to be the rise over run. So here I'm going to go down 3 and to the right. So you always go to the right, but if it's negative, you would go down instead of going up. So we're going to go down 3 and to the right 1. We can go down 3 and to the right 1. However many points you need to draw a line that's as straight as you can be. As long as you can figure out where the two lines intersect. Juan, what is the point that our two lines intersect? -1, -1. So that would be our answer. Let's do the same thing with number 3. So let's graph our first line first. So what is our y-intercept? 1. So I'm going to put a point at 1. And what's our slope here? -1, or we can say -1 over run. So our rise would be -1. So we're going to go down 1 and to the right 1. So down 1 to the right 1, down 1 to the right 1. You can put as many points as you need and just connect your dots. Next, with our second line, here it's not really in slope-intercept form, it's just x equals. So if it is x equals, that means that we're going to intersect the x-axis. Our line touches the x-axis at 3. So I go to 3 on the x-axis, and I'm going to put a line through it. So if it is x equals, your line intersects the x-axis, it touches the x-axis. If it were y equals, your line touches the y-axis. Now, where do our two lines intersect? 3, -2. Perfect. Let's look at 6. So here it's set up in y equals mx plus b form, so we can solve using our intercept. So what is our y-intercept? 3 in our first equation. And what's our slope? -1 over 4. So I'm going to start by putting my y-intercept on the graph. So I put a point at 3. How would I show the slope of -1 over 4? Down 1 and to the right 4. If it's negative, you're going to go down and you always go to the right. You can go in the opposite direction. So if I go down 1 and to the right 4, my line's going to form going this way. So I can go up 1 and to the left 4, but just always think about it for your slope. If it's negative, you go down. If it's positive, you go up, and you always go to the right. But you can also just go the opposite way too. So I can go up 1 and to the left 4. And then I can connect my points. Now let's do the same thing for our second line. What's our y-intercept? -2. And what's our slope? -3/2. So I'm going to start by putting my y-intercept at -2. And then our slope goes in which direction? Down 3 and to the right 2. So we go down 1, 2, 3 to the right 2. Now, since we're running off of our graph, we can go in the opposite direction too. So we can go up 3 and to the left 2. Now I want to keep making points until my lines intersect. So I'm going to go up 3 again and to the left 2. Now where do our lines intersect? -4, 4. Awesome. What if we had two lines that were perfectly parallel? Two lines like this that never intersect. What do you think our answer would be here? No solution. Awesome. So if you have two lines with the same slope, they gotta have the same slope, meaning that they'll never intersect, and they have different y-intercepts, your answer will be no solution. So with 11, there's two different ways that we could solve. You could either put it in slope-intercept form, or you can graph it by finding your x and y intercepts. So for our first line, I'm going to do it that way just so it's a little bit different than what we solved or how we graphed the other two. For the first one, let's find our x-intercept first. How do we find the x-intercept? Not quite. So the x-intercept, think back how we did this before. Plug 0 into y, awesome. So we plug 0 into y and then solve. So here we have 5x is equal to 4. Divide by 5. So x is equal to 4 over 5. Not really ideal because we have a fraction, but let's just finish solving it this way or graphing it this way and see if that'll help us. So our x-intercept, where we cross the x-axis, is going to be 4/5, so a little bit less than 1. Now, in the first equation still, let's find our y-intercept. This is going to be where we cross the y-axis. How would we find the y-intercept? Plug 0 into x. So that would be 0 plus y, so y is equal to 4. So we don't even need to solve there. So we cross the y-axis at 4. So once you have your x and y intercept, you can draw a line. Now we're going to do the same thing for our second line. How would we find the x-intercept? Plug 0 into y. So we have x is equal to 2. So we cross the x-axis at 2. So I'm going to put a point there. Next, let's find the y-intercept. How would we find the y-intercept? Plug 0 into x. So we have negative y is equal to 2. How would we get y all by itself? Divide by -1. So y is equal to -2. So I cross the y-axis at -2. Now we're going to connect our x-intercept and y-intercept with a line. And where do our two lines intersect? 1, -1. Perfect. So let's take a look at 29. So 29, we could either solve by putting it into slope-intercept form, y equals mx plus b, or we could solve using our intercepts where we find the x-intercept and we find the y-intercept. Either way would work. Which way do you want to do? Y equals mx plus b or the intercepts? Sure. Let's rearrange our equation to be in y equals mx plus b. So for the first equation, I'm going to rewrite it up top over here so we have more room. First thing I want to do is add the 2y to move it to the other side. So we have 2y minus 2x is equal to negative 8. What can we do next? Add 2x to move it to the other side. So 2y is equal to 2x minus 8. And then what? Divide by 2. So y is equal to x minus 4. So what's our y-intercept? Negative 4. And what's our slope? 1. Awesome. So we cross the y-axis at negative 4. And our slope is 1. We go up 1 to the right 1, up 1 to the right 1. And we can connect our points with a line. Now let's do the same thing with our second equation. Bless you. First thing I want to do is add 8 to move it to the other side. So I have negative 2y is equal to negative 2x plus 8. Then we divide everything by negative 2. So y is equal to x minus 4. What's our y-intercept? Negative 4. What's our slope? 1. So we're going to put a point at negative 4, and we go up 1 to the right 1, up 1 to the right 1. What do we notice about our lines? It's the same line. So what do you think our answer is? Infinitely many solutions. Or you could say many solutions. So it's not really all solutions. It has to be like a solution from this line. So that's why it's infinitely many solutions, because the line goes on to infinity. So there's a ton of different answers here.